NAT for 1 mark. The plane frame shown in the figure has fixed support at joint A, hinge support at joint F, and the roller support at joint I. So all the joints A to I are considered as joints of the frame, or we can consider them by default rigid. Rigid means there is no relative rotation between these four members. There is no relative rotation I am saying, between these two members. Okay. Now, if the axial deformations effects are neglected, then what is the degree of kinematic indeterminacy? So we have to count kinematic indeterminacy. Okay. So we will be doing it. So very well designed question by IIT. So see, this is a fixed support. So fixed support is going to have 0 degree of freedom. Okay. First of all, we need to know each and every joint, rigid joint, can have all 3 possible degree of freedoms. If their support is fixed, it means all those 3 degree of freedom is going to be cancelled or absorbed by this fixed support. If it would have been a normal case, then each and everywhere we could have added 3, 3, 3, 3, 3 like that. Okay. So it is a free, and here also 3, and here we have to add only 1, and here we need to add 2, 1 for axial deformation and 1 for rotation. Okay. But in this question, they have very clearly mentioned axial deformations. Means we are not saying that in reality axial deformations cannot exist. They can exist, but in comparison to shear and bending deflections, these axial deformations are quite less. So they can be ignored here. Okay. So if I am considering, or if I am ignoring the axial deformation, then how is going to be my counting? So in normal case, the answer would have been 0, 3, 3, 3, 3, 3, 3, and here it is 1 plus 1, 1 for rotation and 1 for translation, and here only 1. So this would have been my normal answer, no, without axial deformation part. Okay. But in this question, we need to consider axial deformation, so we need to see what all are the changes which we can expect here. Okay. So now listen to me. Here fixed support 0. This is a hinge support, only 1 rotation is allowed. This is roller hinge, rotation and translation in x direction both are allowed, but due to the axial rigidity of Fi, we are going to have only 1 here, that is theta z. Okay. Here also 1, that is theta z. Here only 1 deformation is possible. Now why 1? Why not 2? Because AB cannot extend. Okay. BE can go in the forward direction, but BF is going to give it the bracing effect. So delta X and delta Y will be ignored here. Similarly, delta X and delta Y will be ignored here. So only 1 theta Z will be here. So let me explain you. Let me write each and every portion. Theta Z. Now coming on to the D, here also no delta X is possible, no delta Y is possible. Here also 1 theta Z. Here also 1 theta Z. Here delta X is not possible, but delta Y is possible. So here total 2 degree of freedom. 1 is delta Y and 1 is theta Z. And here again 1 degree of freedom. Okay. So this one is also theta Z. Now we can count them all. It is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So correct answer will be, what is degree of freedom? What is degree of kinematic indeterminacy? Okay. So it is a summation of all the degree of freedom available at joints. Okay. So we have total degree of freedom at 9. So correct answer is 9.